All right, guys?
What flavor is that?
Yes, number 4. All right, I've got my first request. Guys, please make sure that you have your reviews out. I will be collecting these on Friday for completion credit. So anything that we do in class together, I would expect to be correct. I will be posting all of these. And again, on Friday for the test, I'm going to check these for completion credit. All right, number 4 was our first request. A Pike High School Teachers Committee is interested in PHS seniors' plans after high school. Specifically, they want to know the percent of graduating seniors who are planning on attending college in the fall. In order to gain the information they are after quickly and efficiently, the committee is going to sample the senior class. All right, so some things that jump out to me. They're going to sample the class. They're not going to talk to everybody.
The senior class.
Yes. They won't ask all seniors. But all seniors is who they're interested in, right? Yes or no?
Yeah.
Yes. So the population is all of the PHS seniors. The parameter is what they want to know about the whole population. What is it that they're wanting to know?
The percentage of graduating seniors who are planning on attending college in the fall.
Yes. That is their parameter. The percent of all the PHS seniors that are planning to go to college in the fall. Describe in detail how the committee could collect an unbiased sample from the population. Tell me.
From a volunteer, because you volunteered, you're not being biased. They're offering to be a part of it. Not forcing them.
Not forcing them is important, yes.
Make them feel comfortable.
In order for it to be unbiased, it's got to meet a couple parameters. The biggest one is that it has to represent the whole population. Must represent the whole population. If I asked for volunteers, do you think that I would get a good representation of the senior class?
Yeah. You won't, because it probably probably be just mainly the nerds.
Fair assessment. So even though I'm not forcing anybody, and there's no bias on my part as the researcher, would my sample be unbiased if I took volunteers? Would the sample be unbiased? That means it has to be representative of the population. No. Again, I didn't do anything to make sure that it wouldn't represent the population, so I didn't bias it, but it still ended up being biased because I just had volunteers there. I still wouldn't want to force anybody to participate that didn't want to, but most people, if they're asked, wouldn't mind answering the question, right? If you just walked up and said, like, hey, are you planning to go to college in the fall? Yeah, it's just like a yes, no. Most people are comfortable with that. And if they're not, you move on. So So I want to be looking at some of the different methods that we've talked about. Let me list them out, and we'll pick something that we think would work. We've already brought up volunteer sample, but a volunteer sample is always going to be bias. A convenience sample, this one I wouldn't be asking for volunteers, but I'm like, I want to know this, so I only ask you guys because you're right here and you're easy for me to access.
Bias.
That would also be bias. Then there was the simple random sampling. That would be like names in a hat or like a lottery style. Have you guys ever seen when they draw the lottery numbers for Powerball and there's a whole bunch of ping pong balls bouncing around? That's a simple random sample.
It can be biased because it's random.
Exactly. There's something called systematic sampling. You pick a random place to start, so you still have that random element, but then after that you'll go to like every 10th person or every 35th person. Yeah, you have a system. That one is not a bias method.
How?
Because you randomly pick where to start, and then you don't know who's the 35th person in line after that. You just have some method for picking out. But it's not bias.
You just have a pattern.
It has a pattern to it, yes. Then there's cluster sampling. Asking, so you're going to take your whole population. You have to make sure that they're in little clustered groups. Here at school, that would be like classrooms. And then you're going to go to some of those clusters, but not all of them. Because remember, we just want to sample. We don't want all the seniors. And then there's something called stratified. In stratified random sampling, you want your population divided into groups where there's something the same about all the groups. Like maybe you divide them into male and female. Maybe you look at athletes versus non-athletes. Maybe you look at, this wouldn't work for this example, but if I divided everybody by grade level, so freshman, sophomore, junior, senior, and I ask some from each group, that would be stratified. We're going to pick out one of these methods and talk about how we could pick out a sample. Which one do you guys want to use? Simple sounds good. So if I wanted to use simple random sampling, I would take all seniors. I'm going to take their ID numbers, because that's probably easier for me to print out than everybody's names. Take all seniors' ID numbers. Write them on, why don't we do it on popsicle sticks? Yep. I'm pretty sure I misspelled popsicle. If somebody knows how to spell it, please tell me. There we go. Write them on popsicle sticks. How many should we talk to so that it's a good-sized sample? 100, okay. Pick out 100 sticks randomly. And sample those seniors. That would be one way that I could collect a sample. What is the statistic? So the statistic is what I find from my sample. It should be the same as the parameter.
Percent of all high school seniors in college.
Except I'm not talking to all the seniors. I'm only talking to the sample. So this would be the percent of the seniors who get called down and answer my question that are planning to go to college. So the percent of seniors picked for the sample that are going to college in the fall. The statistic is what you calculate from the data that you've collected. The parameter is what you want to know about everybody. So that's like your driving question. The statistic is going to be your close estimate for the parameter. Since you're not talking to everybody, you're going to estimate it using your statistic.
Question.
Yes.
So on the test like this,
Mhm.
is it like giving an answer, or are we just, what you're looking for is basically us being able to identify like using words, using critical thinking, common sense?
So I might give you a situation, like if you look down at number 5, I ask what is the parameter and what is the statistic. I might give you a situation and ask you for these different pieces that would be part of that story.
We don't have to actually calculate?
You do not have to actually calculate on a question like this. No. You don't have to do any calculations for these. Anything that you have to do calculations for on the review is fair game for me to ask you to calculate on the test. But if I'm not asking you to actually calculate it on the review, I'm not going to ask you to calculate it on the test. Is that fair?
Yeah.
Okay.
So basically we're just writing a lot, and then the only thing we're calculating is basically when it comes to the mean and stuff.
Mm-hmm. When we're talking about statistics, yes, statistics is a lot of explaining what you found and the meaning of it. And the calculations themselves are either going to be things like mean, median, and mode. Because statisticians, people that do this for a living, they'll use technology to calculate the standard deviation and things like that. So things that are easy for us to calculate by hand, those would be the types of things that I would ask you to calculate for me. What else would you guys like to see from the review?
Are these going to be the same question, like not same questions, like mixed around?
Similar types of questions, yes. There's nothing on the test that is not covered on the review. There will be no surprises on the test. I might ask it in a different way, but it'll be covering the same big ideas. Sean, you had a question? Mm-hmm. What else off the review would you guys like to see me work through?
What does this all cover?
Number 2. What do you mean?
The lessons we've been going through. Like, recently the margin of error, is that going to be decided here or no? Or is that our next unit?
That is not our next unit. Margin of error, I do not believe is on this test.
Cool.
We covered it because it's an important concept that I wanted you guys to be familiar with, but it is not on this test. Question number 2. All right, we are supposed to fill in 2 different pieces on this diagram, and then we're going to calculate something here and determine whether or not there are any outliers. So we're going to use the word bank to talk about the name of each of these pieces. When I'm looking at a box plot like this, down here, that's my minimum. That's the smallest value.
So the other one is maximum.
Yep, over on this other end is the maximum. All right, so we've used minimum and maximum. Right in the middle of the box
Median.
is the median. The left edge of the box is the lower quartile. And the right edge of the box is the upper quartile.
Would you like some two-way tables that fit all the data points?
Yes, thank you. I appreciate it. All right, so that's all the stuff that we needed as far as the names of these different places. Lower quartile, upper quartile. Now we're going to do some calculating. To do these calculations, I'm going to take the observed data, our collected data right here. I'm going to put it in order from smallest to biggest. What is the smallest value in that data table?
0.
0. All right. And what would go next?
50.
50.
60.
60. So
73
50,
times.
60. We only have 60 once?
2. Another 60.
There's another 60. And then KT, you said we have 73 times. So 70,
90.
70,
80.
70, 70, 70, 70. And then we have 80,
92 times.
92 times,
And 100 2 times.
and 100 2 times. All right, we got them all, and they're all in order.
Subtract 100 minus 0, which is 100. That's the range.
Yes, that is correct.
What?
It's not one of the things I asked about, but yes. So the range, 100 minus 0.
And now let's find the median.
Let's talk about the minimum and the maximum first. What is the minimum?
0.
0. So that's the value that I would have down here. What is the maximum?
100.
100. That's the value that goes up here. Now we're going to find the median.
Thank you. Let's cross out until we get to the value.
Sounds good. All right, so 1, I'm doing check marks so I can still see my numbers. 2, 3, 4, 5. There's 2 numbers in the middle.
70 plus
70.
70 plus 70 divided by 2. Because what we're trying to do is find halfway in between 70 and 70.
70.
70. That's our median. I'm going to draw a big line. This line right here is my median because it's halfway in between these two values.
Question.
Yes.
Now, what if it was 70 right there, right? But then it was 75 to the right. Do you pick 70 because it's smaller than the other number to the right?
No. If there's 2 numbers in the middle, like if this went 0, 50, 60, 60, 70, 70, 75, 80, 90, 90, 100, 100, is that what you're asking?
Yes.
Then we would add the 70 and the 75 together and cut it in half. Because we want to find halfway in between the 2 middle numbers. If there's 2 middle numbers, I want halfway in between those 2. And the way I do that is to add and divide.
But if it's like odd, then we'll automatically have a median because
We would still have a median. It would just have a 0.5 in it.
it's weird.
Kind of like if I wanted to know the halfway point between my house and Pike High School. I live 7 miles away from here. How far is halfway between my house and Pike High School? If I live 7 miles
But
away.
ain't that's getting into the quartile. I'm talking about like the regular median.
3.5. I'm just talking about halfway in between the two. Between my house and the high school, it's 7 miles. So halfway would be 3.5 miles.
Well, 3.2.
Not if it's 7, it'd be 3.5.
She said 7.5 miles.
I think I'm getting my stuff confused. 7 miles between me and the high school.
That was
Yeah,
That'd be
I feel
3.5.
like now,
Okay.
I feel like I did this homework.
That's okay, we'll talk about it. We'll keep talking about it. Okay, so median, halfway in between if there's 2 in the middle. If you cross out and there's just a single value in the middle, that's your median. You don't have to do any adding and dividing. Thank you. Thank you. All right. So now I need the lower quartile and the upper quartile. For the lower quartile, I'm only looking at the numbers smaller than the median. So just these right here. And we're going to cross out and find the middle of those. So where's the middle of just these smaller numbers?
60 and 60.
Yep, right here. So I do 60 plus 60 divided by 2.
60.
So 60 is our lower quartile. Also gets called Q1.
You said divided by 2.
If it falls in between 2 values, you add them and cut them in half. Yep.
If there's one value, we still gotta cut it down.
No.
Thank you. That's what I was.
If you cross out and go to the middle, and there's just a single number in the middle, you just grab it and that's it.
Thank you.
The only time you have to add them and cut it in half is when you cross out to get to the middle, and there's 2 numbers in the middle.
Cool.
All right. For my upper quartile, I'm going to look at only the numbers that are bigger than the median. And we're going to cross out and find the middle of that.
90.
90. Yep. It's going to be 90 plus 90 divided by 2. So we get 90. That is my upper quartile, Q3.
Wait, is that a question on?
Mm-hmm. How are we doing? Anytime you cross out to find the middle, if there's 2 numbers in the middle, you have to add them together and cut it in half. If you cross out to find the middle and there's just 1 number in the middle, you just grab that 1 number.
Is this next one 60 minus 1.5?
Gives you 90. Yeah. If you've got 2 of the exact same number, because what we're doing when we add them and cut it in half, we're trying to find halfway in between those 2 numbers. Well, if my 2 numbers are the same, halfway in between would be the same as those. Calculating the IQR, I'm going to take my bigger quartile, Q3, and I'm going to subtract my smaller quartile, Q1. So how big was Q3?
30.
Or the answer.
Yes, the answer is 30. 90
Where'd you get 35?
minus 60,
Oh,
that's how I get 30. That is the IQR.
oh.
So far, so good?
Yeah.
Okay. This is the level of calculating that I'm going to be asking for. Are there any outliers? To test for outliers, I have to do 1.5 times the value of the IQR. So I'm going to do 1.5 times 30,
45.
45. With this 45 right here, I'm going to do Q1 minus that number. And then I'll do Q3 plus that number. So Q1 was 60. So I'm going to do 60 minus 45. 15. Are any of the values in our data table smaller than 15?
Yeah. 0.
0. Okay. 0 is smaller than 15. Let me scoot this up a little bit. I feel like I'm running out of room. Make this show up a little bit better here. Okay. What is my Q3 again?
90,
90. So I do 90 plus 45, and I get what?
135,
135.
It's bigger than all the things, so.
outliers.
Yep, 135. So if there's values on the data table that are smaller than 15 or bigger than 135, then we have outliers. So 0 is an outlier. I'm going to write this in a different color.
Is
0 is an outlier because it is smaller than 15.
is it smaller than 45? Because that's not what you are. Why is it, what's 15 got to do with
15 is my lower quartile minus how big that box is. Anything that's smaller than that, anything that's further away from my lower quartile than the width of this box, or 1.5 times the width of the box, sorry, is an outlier. So-
let me look at it as this, because that's confusing. I'm gonna look at it as if that equation that you did.
This guy right
because
here?
That, so yeah.
Yep. Anything smaller than this would be an outlier. Anything bigger than this would be an outlier.
Cool. That's okay.
Yep.
I'm just gonna picture 15 is smaller than any other number on there. I mean,
15 needs to be the smallest number, and if it's not, then there's an outlier. 135 should be the absolute biggest number.
yeah, nothing's up there is bigger than it.
Exactly. So there's no large outlier because nothing's bigger than this.
Because 0 is a part of that 60 minus 45 means that's the smallest number. That's smaller than 15.
This 0
Is the
right
outlier.
here, this is my outlier. Let me go up and mark that on the data. This is an outlier.
Number 3.
Yeah, we can do number 3. All right. And if you guys want to talk some more about outliers, we can absolutely talk about that. We still have tomorrow to study too. Number 3, identify whether the following situations would have positive correlation, negative correlation, or no correlation. So a positive correlation means that the two variables move together in the same direction. A negative correlation means my two variables move in opposite directions to each other. And if there's no correlation, then the way one moves has absolutely no impact or effect whatsoever on the other one. You wouldn't be able to make predictions if you knew something about one of them. So, like when I look at part A, total driving distance and amount of gas in the tank. If I go on a long road trip so that my total driving distance is really high, what happens to the gas in my tank as I drive farther and farther and farther?
You're losing more gas.
I'm losing more gas. So as the miles go up, the gas in my tank goes down. Are those moving in the same direction or opposite directions?
Opposite.
Opposite. So that would be a negative correlation.
Can I see what I think on the next one?
Yeah.
So you can see if I would better understand it.
Mm-hmm.
I think B is positive.
Number of pets owned in the high school GPA. So if I go out and buy my daughter 3 new fish, is her GPA going to improve?
No.
Is her GPA going to get worse?
No. It's no correlation.
No correlation.
So no correlation, I can define it as something that is irrelevant.
Yes, basically, these two aren't, they have no relationship to each other whatsoever. Finding out information about one of them would not help you at all make better predictions about the second one. So let's look at C. Price of a new car and the number of upgraded features. So like there's the basic model and then they try to upgrade you on all the stuff. Do you want the,
Yeah.
Positive correlation,
tell me why?
because everything's new. Like, meaning everything is getting upgraded. Like, it's a new car, so it's new, and then new parts.
Yes. If you add anything onto that car other than just the basic features, the price is going to increase for each new feature you add. So more features, higher price. Fewer features, lower price. They move in the same direction with each other. What about D? Total on-court practice time and the percent of free throw shots made.
I think no correlation.
No correlation, no relationship between how much you practice and...
I mean, yeah, I was thinking because, like, you can't tell whether how much the person makes out of the percentages made of the shot.
But if you see somebody that's sinking like 90% of their free throws, they probably got that good at it from practicing, right? If you want to get better at something, what do? You practice. Spend more time practicing. You should see your percentage go up. Positive. Average number of hours spent practicing piano each week, and the average amount of calories consumed each day.
No correlation.
No correlation. Last one, number of children and the average amount of free time you have each week. Negative. More kids you got, less time you have to spend doing whatever you want. Negative correlation. I'm silly enough, I use like my thumbs up and thumbs down as I'm doing these on my own, thinking about them. Like, okay, if the one goes up, what would I expect the other one to do? If I don't have any expectations for the other one, that's where I have a no correlation. We've got about 10 minutes left. What else would you guys like to see?
I don't know.
12?
I don't want to do one. I just want to know what do it mean, the context of the situation.
Context of the situation. So you're going to look at what the graph is talking about. In that case, it's men and women and their heights. So what would it mean for either the men or the women to have a larger standard deviation? Like,
Okay.
yeah. Number 12. All right, scatter plots.
No. I should have been.
The more it looks like a line, the closer it is to 1. If it has a negative slope, it's going to be a negative R value. If it has a positive slope, it's going to have a positive R value. Let's go through and just say whether we think they're positive or negative for starters. This one, any idea whether that's positive or negative, or could you just say, like, I have no idea?
I have no idea. This is
No
all over the place.
association.
All over the place. No association. What about the one next to it?
It was very positive.
Positive. What about the next one?
Negative.
Negative. And then positive again.
What does it mean for it to be strong or moderate? What's that?
The more it looks like a line, the stronger it is.
Yeah.
So could it be strong?
Mm-hmm. What do you think about the next one here?
It definitely looks like
Negative.
mine.
Negative, and the one next to that?
Negative.
Negative, and the last one?
Positive.
Positive. Oops, wanted to do that in blue. All right, so then when we talk about strong, moderate, and weak, if it looks like a line, like you could grab a straight edge and draw a line through it, it is very strong. So this one over here right next to our no association, this one is most definitely strong. The more cloud-like it looks, the more scattered it looks, the weaker it is.
So negative.
Yes, this one would be weak.
This would be moderate.
Yeah. The next one I would call moderate because why?
It's not really close together.
Yeah. It's not as spread out as the one next to it, but it doesn't look as close to being a line. So I would call this one moderate.
Strong.
Yeah, strong.
Strong for this one because it looks a lot like a line.
Moderate.
Moderate.
Weak.
Yep, and weak. Looks good. All right, now we're going to pick out the R values that go with these. The closer the number is to 0, the weaker the correlation. So the one that we said had no association, which R value should we use for that?
0.15.
We're going to use
Oh, yeah.
0. That's the smallest, that's the thing that's closest to 0 here. So I'm going to put that right there. Let's go through and look at just the positive ones next. So I have positive 0.99, I have positive 0.75, and I have positive 0.45.
This one's 0.99.
Yeah. This is very strong. So that's going to be my 0.99.
Now, why you took the other numbers? Why did you take
I'm only going to look at the positive graphs first. Because it's going to, so positive graphs, positive correlations will have a positive R value. So I know that this is a positive number, this one's a positive number, and this one's a positive number. Because when I look at the graph, they all have positive slopes. We know that one's 0.99. I've got to make a decision between the 0.75 and the 0.45. 0.75. Why?
It's spread out a little bit more than the first one.
Spread out a little bit more than the first one, but not as much as the one after that. 0.75 is closer to 1 than 0.45. 0.45 is closer to 0. So that's going to be the weaker one. So far, so good? All right. Then we're going to go look at the negative ones here. And I'm going to look at my 3 negative graphs. We have negative weak, negative strong, and negative moderate. When I'm thinking about strong and weak on this, I already know it's negative, so I'm going to ignore the negative sign in front of it, and I'm still going to look for which one's closest to 1, or in this case, negative 1. So that negative 0.99, this is the strongest. That's the one that looks the most like a line. Which one would that be?
The one that says negative strong.
The one that says negative strong. Negative 0.99. Where should I put the negative 0.75?
Negative
Moderate.
Negative moderate. And so process of elimination says negative weak
Moderately cheap.
is the negative 0.45. Does that make more sense? Cool beans. Bell rings in 2 minutes. Please keep working your way through this. I'm going to take more questions tomorrow. I've definitely got 2 questions that I want to make sure that we hit on tomorrow. Please, before class, make sure you've done number 9 and number 11. I'm going to start with 9 and 11. And then I'll take any other questions you guys have.